Hello Year 11s, welcome back to Term 2. In the second booklet that you would have received, we're actually going to be continuing our work on further functions. And in this first section, what we're going to be looking at is this idea called points of intersection. This topic isn't actually a very different thing. You've actually had a look at this when we were solving simultaneous equations. So when we solved simultaneous equations, what we did was we used, so what I'm going to write down here is we did this at the beginning of our kind of little working at home from online. So what we used was we used two particular methods of solving simultaneous equations. So we used the substitution method, and we also used elimination. So when we were, this was the first thing I think we did during that learning from home when we started doing learning from home. Now what I want to do in this section is actually link this idea of solving simultaneous equations with finding points of intersection. So what a point of intersection is, I'm just going to highlight this, I'm going to zoom in over here. A point of intersection. A point of intersection is a coordinate, a point, or i.e. coordinates on a graph where two graphs meet. So for example, when we solve simultaneous equations, we might have seen this type of equation. We've got two equations, y is equal to x squared and y is equal to x plus 2. These are these two equations on the left here. So what we did was we would use, probably in this scenario, I would probably use the substitution method to solve these two equations. And after I've solved these two equations, I would get x is equal to 2, y is equal to 4, and x is equal to minus 1, y is equal to 1. You can check those solutions yourself if you would like to. What we're doing here is, and we're going to actually link that to what solving simultaneous equations actually looks like if we were to put this on a graph. So if we were to graph these two equations, so y is equal to x squared. So if you have a look on the right, I've actually graphed y is equal to x squared in red, and the line y is equal to x plus 2 in blue. If you have a look, those two graphs, they actually end up touching each other at these 2 points, -1, 1, and 2, 4. These coordinates actually correspond to the solutions of our solutions that we got from solving our two simultaneous equations. So when we're solving simultaneous equations, what we actually can find is we're actually finding the points of intersection. When we find points of intersection, that's the same as solving our simultaneous equations. But the way you can think of this is when you solve simultaneous equations, we're often doing that algebraically. So we're using algebra and manipulating our equations algebraically. But when we're finding points of intersection, this actually is when we look at it graphically. So what happens when we actually draw these graphs onto our Cartesian plane? And we've actually done a bit of work on graphing linear equations, linear functions, but also graphing quadratic functions as well at the end of last term. Now, just to sum up these two ideas, let me just go through this table with you. So, algebraically, when we're solving simultaneous equations, what this looks like graphically is we are finding points of intersection, i.e. where do the graphs touch? So we're trying to find where the graphs touch each other on the Cartesian plane. So when we're solving simultaneous equations, that's what we do algebraically. Graphically, what this corresponds to is just finding points of intersection on a Cartesian plane. When we're solving simultaneous equations algebraically, the next thing is that we use two particular methods. So we use the elimination method and the substitution method. We've gone through that last term, and if you need a bit of help just going through that, have a look at the notes that we did last term. Graphically, what this looks like is, well, if you have a look, all we do is we look at our two graphs and then we look at the coordinates, and those correspond to our all we do is we look. So we find points of intersection by looking at where graphs touch. All we're doing is we're looking. We're going, okay, where do these two graphs touch? So for example, we saw that it touches here and also over here. That's what we do. Now, when you're solving simultaneous equations algebraically, your solutions are pairs of values for pronumerals. So for example, what I had written up above was that we have two pairs of solutions. So we have x is equal to 2 and y is equal to 4, and x is equal to minus 1, y is equal to 1. However, when we're solving them looking at it graphically, points of intersections are coordinates. So here, solutions are coordinates. And with all coordinates, you have an x value and a y value. So for example, if we took our solutions from our algebraic solving of simultaneous equations to x is equal to 2 and y is equal to 4, that would correspond to, so I'm going to draw an arrow here. This first solution would correspond to, well, the x value is 2 from over here, and our y value is 4 from over here. So here, when we're looking at it graphically, our solutions are actually coordinates. So the solutions are coordinates. And if we do the same thing for the other set of solutions, we end up getting that we have our other coordinate as -1, 1. So here we go. Here's kind of like a comparison between solving simultaneous equations using algebraic methods and what that actually means for us when we're looking at it graphically. So what the kind of geometric significance of solving simultaneous equations are. What I'm